Okay. So what we have discussed in last class, can anyone recall the topics of symmetrical component, right? Symmetrical component in terms of phasor quantity like voltage and current, right? So
Yes, with
have,
sequence
have
impedances, sir.
sequence impedance we have covered. Okay, fine. If we have covered sequence impedance, then in that case, let me share one. Sequence impedance, I base some problem so that you can get the idea. Sequence impedance, this one. So here you can see some voltage which is given in terms of which domain? ABC, right? And
Yes,
if it is in ABC domain, is it balanced or unbalanced from that given information?
unbalanced.
Unbalanced. How can you justify that it is unbalanced? What is the reason?
Because it's a
All
1,
are
2,
not
3
working.
নাই স্যার মানে 0 1 2 নাই দেখা
012 মানে V0 VA V1 V2 ওইটা
হ্যাঁ স্যার হ্যাঁ স্যার ওটাই তো মনে হচ্ছে হ্যাঁ
না it is actually VABC, right? It
Yes,
is
sir.
not in 012 domain. First of all, you have to check which domain it is given, whether it is
Yes,
given
sir.
in ABC domain or 012 domain. If it is ABC domain, that means this value is VA.
Unbalanced.
Okay,
Yes.
VB VC. So if
Yes,
they
sir.
are VABC, why it is unbalanced or what is the reason it is unbalanced?
Oh, because it is the summation of all the 0 1 2s তার মানে it is মানে একটা matrix made up of few I don't know sir আপনি বলেন স্যার
আচ্ছা আর কেউ শেয়ার করতে পারো why it is unbalanced VABC? Anyone else? Sabrina aso?
Yes, sir.
Why ABC VABC given information it is balanced or unbalanced? And unbalanced. If it is unbalanced, how can you justify that it is unbalanced? Say for example, if I say it is unbalanced, how can you defend your logic? From that given information, what is the value of VB? Can you identify VB?
Yes sir I think I can sir
What is the value of VB here?
Sir VB
VB
VB তো sir it is the summation of I think আপনার একটু মাথায় গুলা যাচ্ছে সবকিছু so it is a summation of sir 100 plus ওই যে 1 angle minus 155
সামেশন হতে যাবে কেন it is only that value, right? সামেশন তো তুমি আরো যদি ভ্যালু কে ইন্টিগ্রেট করো in that case you have to consider summation. It is the single value.
Yes,
single
yes,
value
yes.
This one, so it is VB. So
yes.
What about VC? 80 100 angle, right?
Oh sir এগুলো একটা ভ্যালু স্যার
Yes,
sorry
that is the different value. That means VC, VA, VB. Okay.
Yes sir.
Now you have got that. Now if it is VA, VB, VC, okay, it is in matrix form. Okay, matrix form VA, VB, VC notation. So it is individual value. Okay. So
sir there is a gap in between তো স্যার আমি ভেবেছি দুটো ডিফারেন্ট ভ্যালু সো আমি কনফিউজড হয়ে যাচ্ছি
different value তো VA, VB, VC তিনটা different value তো
না স্যার ওটা বলছি না স্যার 200 তার মাঝখানে একটা বড় গ্যাপ তারপর ওর অ্যাঙ্গেলটা
এই গ্যাপ এটা তো অ্যাঙ্গেল this is the phase angle information.
হ্যাঁ এখন বুঝতে পেরেছি স্যার
আচ্ছা যদি এটা বুঝো তাহলে now can you justify that it is balanced or unbalanced?
স্যার এটা again sir I think it is unbalanced because এটা কি স্যার ব্যালেন্সড হওয়া উচিত তাহলে আপনি কি এটা বলতে চাচ্ছেন
না আমি বলতে চাচ্ছি না আমি যদি বলি যেটা তুমি বললা unbalanced if I say it is balanced how you can defend that this is unbalanced? That's my question. You have to know the logic, or you have to know why it is so.
ওকে 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 ও ওকে স্যার, এক মিনিট স্যার, এটার মাঝখানে অ্যাঙ্গেল গুলো স্যার দেখলে তো হয়। এখন আমি একটা অ্যাঙ্গেল দেখি, তাহলে বুঝতে পারবো।
দেখো, you can check the angle.
হ্যাঁ স্যার, এ বি সি, তাই না স্যার? তাহলে আমার এ আর বি এর মাঝখানে ডিফারেন্স তো হচ্ছে স্যার 120 বেশি স্যার। আবার
কত
বি আর সি
আছে?
এটা আসে হচ্ছে আপনার
বেশি আছে। আচ্ছা, হ্যাঁ, হলো। তারপরে
মাইনাস মাইনাস 170 180 আসতেছে।
স্যার
তো
সবগুলা
এ
অ্যাড করে 0 হবে না এই জন্য?
হ্যাঁ, that is one logic, but
Yes, sir.
just from observation, that is the
Yes, sir.
after calculation. But from that given value,
Yes,
you
sir.
can check
Oh,
the
sir.
magnitude, right?
Magnitude, sir. Magnitude. Yes.
Their magnitude is not same. If it is balanced, it should be same, right?
Yes, sir.
You can also justify in terms of angle also. That means you might have magnitude difference. That means magnitude may not be same. That is the unbalanced behavior, one kind of unbalance.
As an
Or
angle. Sir.
yes, it should satisfy the 120-degree difference between different phase. That is another option. So in
স্যার
that
এটা তো বলেছিলাম ফার্স্টে স্যার।
in that case, actually, the two conditions are satisfied, right? For the
Yes, sir.
unbalanced scenario. ঠিক আছে? So
Yes, sir.
you will have two condition to justify that it is unbalanced. Now, second option or second question, if it is unbalanced, we know that we can generate its sequence component, right? V0,
Yes, sir.
V1, V2 in terms of different phase. Now, if it is
Yes,
so,
sir.
we know sequence impedance as well from last class. If you can check or recall, there was ZS series impedance as well as ZM mutual impedance. Okay, so try to collect these three information. That means VA, VB, VC as well as ZS and ZM.
স্যার এখনো করব?
First of all, yes, first of all you have to collect those data. Okay, then what you are asked, that you have to determine load sequence impedance matrix, which is Z012. To generate Z012 from last class, Z012, how can we find Z012 in terms of matrix? Have you collected this data?
স্যার আপনি একটা ফর্মুলা দিয়ে দিয়েছিলেন স্যার yesterday.
হ্যাঁ, আমি দেখাচ্ছি। I will show you the formula. Just collect those information. Okay, 225 degree. Second one, 100 minus 155. Third one, VC 180, 100 degree.
স্যার আমাদের এখানে নিউট্রালের কোনো ইম্পিডেন্স দেয়নি স্যার।
Yes, that is another good question, that it is not given in terms of problem that should be there ZN, right?
Yes,
But
so we
it
take
is
it to be 0.
mentioned, yes, that should be 0. And another thing, it is mentioned solidly ground in this problem statement. You can see there, the load
Yes,
and source neutral are solidly grounded. Regarding ground, okay, regarding the neutral ground, there might be three possibility. Okay, remember that. Regarding grounding option, you have three different option for grounding. One is solid ground. That in that case, Zn value is 0. First option. Second
Yes, sir.
option, you might have resistive ground. Okay, resistive impedance information will be there. Third one is reactive ground. That means in between neutral and ground, earth, you might have reactive component to check the unbalanced current, which is due to short circuit situation. Okay, so three possibility you may have regarding grounding option between neutral and earth. Okay, in this case it is solid ground. That means you will have ground connection, but in solid conductor that doesn't have any impedance information. Zn is 0 for this case. So you will have three VA, VB, VC as well as ZS, ZM and ZN. Find Z012 at first.
Sir, one small question.
Yes.
Sir, solid ground so Zn equals to 0. Are there any fixed values for resistive and reactive ground?
Resistive reactive ground information, it will be given in the problem
sir.
statement. Okay.
Okay, sir.
If it is there, it should be mentioned.
Okay.
It will be given. So that will be different than the solid ground information.
Yes, sir.
Try to check the problem statement which is given in the problem. So if you have these three as well as ZS, ZM, Zn, find Z012 and give that response to chat box.
Sir, এটা কিভাবে দিব স্যার? এটা তো ম্যাট্রিক্স ফর্মে আসছে অ্যানসার স্যার।
ম্যাট্রিক্স ফর্মে আসছে তো? ম্যাট্রিক্স ফর্মে দেয়া যায় কিন্তু। দেখো কিভাবে গ্যাপ দিয়ে দিবা, মানে একটা দিয়ে ব্রেক দিয়ে দিবা। ম্যাট্রিক্স আমরা হাউ ক্যান উই রাইট ম্যাট্রিক্স ইন ম্যাটল্যাব অর সামথিং দ্যাট।
আমি তো আসলে ফোনে স্যার, সো ওর জন্য একটু অসুবিধা নেই স্যার, অসুবিধা নেই স্যার, আমি দেখছি স্যার।
Sabrina, have you determined those Z012? Beside that, what are there?
Yes, sir. করছি স্যার।
Acha, okay, fine. Actually, you can do that by that matrix multiplication or the simple expression. Actually, what you have to do, first of all, the sequence matrix, then symmetrical component of voltage, that is V012. VABC is given, so you can find V012 as well. Symmetrical component of current I012. As you have V012 determinant value and Z012, you can determine I012 from there, as well as load phase current. Okay. Acha. Do I need to show the equation for that? Okay, this was the Z012 formula in terms of ZS, ZM and Zn. For this case, Zn is 0. Detailed discussion regarding derivation was discussed in last class for that Z012, which is sequence impedance. So those who have completed the calculation for Z012, they can find V012. How can you find V012?
Sir, multiplying this with A inverse.
V012 A inverse, right? Okay,
It's
V0, yes, V012 will be A inverse into VABC.
yes, sir.
ABC is there in your hand, and you have to multiply that with A inverse. A inverse matrix is given here. You can collect that from there. A inverse matrix. The first part of this equation Z012 is A inverse, so you can take that info.
So the value of A is
1,
1 angle 1 to 120.
right. $332. Are you there? $334. একে পাচ্ছি না। 334 কি সাইফার ছিল না? 334 আছে। Saifa, are you there?
Assalamu alaikum, sir.
হ্যাঁ, ওয়ালাইকুম সালাম। Have you done the registration for the short course?
Sir, I will, inshallah, sir.
Okay. Have you got the link to where you have to do that registration formality?
Yes, sir. CRs have given that.
CR has given. Okay. What about Z012? Have you determined Z012?
Sir, I was facing some.
স্যার আপনি ডেকেছিলেন
কে?
স্যার 332
332, হ্যাঁ। What is the progress regarding short course registration?
স্যার আমি লিংকটাতে গিয়েছিলাম ডিটেইলস দেখেছি তো আজকে আমি রেজিস্ট্রেশনটা করে ফেলব
আচ্ছা, ঠিক আছে।
থ্যাংক ইউ
Registration করার পরে you can mail that link where what I have mentioned in chat box regarding
Yes,
the
sir.
payment or other thing,
Yes,
or for the confirmation or something like that.
জি স্যার
When you register, you can make a mail to that link, to the email after registration done regarding the other procedure to complete that registration. Okay. So V012 Have anyone done VA V?
স্যার এটা একটু লম্বা আছে স্যার, একটু করছি স্যার, এক
আচ্ছা
মিনিট।
করো। So those who have completed Z012 information, it will be 832 for Z0, 820 for Z1, 820 for Z2 as well. That is the actually corner or diagonal element, which is Z012. Remaining parts are 0. And V012 information will be 47, 57 angle, 112 minus 0.03 and 61, 45 degree. Have you made the calculation for V012? Okay, those who have completed, they can check the response. When we have V012 and Z012, we can determine I012 from them. Yeah. Like the simple ohmic relation, you can generate I012. And if you have, yes.
Sir, one small question. To find V012,
Yes.
we have to multiply A inverse with VAB, right, sir?
VABC, right.
ওকে, কিন্তু স্যার আমার কেন যেন মিললো না স্যার।
মিললো না, কিন্তু
না।
মিলছে তো কারো কারো।
ওকে স্যার, ওকে ওকে।
কারো কারো রেসপন্স আসতেছে, আবার চেক করে দেখো। চেক ওয়ান্স।
ঠিক আছে, হ্যাঁ স্যার, ইয়েস স্যার।
কোথাও কিছু সিলি মিস্টেক করলা কিনা। Sabrina has done that in correct way. So up to now, you have the idea of individual quantity like current or voltage or impedance, right? That means individual phasor quantity. It may be
Yes.
unbalanced in terms of individual quantity. If it is voltage quantity which is unbalanced, you can generate its component based on Fortescue theorem, as well as for current and impedance as well. That means they are individual quantity. But if we want to apply that in total, that means all those components in a circuit or circuit is unbalanced or system is unbalanced. In that case, what we have to do? That part we will discuss now. Okay. So those who have tried to generate V012, they can try it once again to check that correction. And I012 will be generated from those Z012 and V012. Okay. And if it is IABC, you can find also that, right? The phase current. This is the sequence component I012. That means it is in 012 domain. But if you are asked to generate its equivalent ABC domain, you can do so, right? IABC. To do that, what you have to do? If you want to find IABC,
Yes.
as you have determined I012, what you have to do?
So multiply I012 with A.
Right. A operator with I012. Then you will get that IABC as well.
Sir,
Okay.
একটা ছোট question. Sir, is the V012 2 by 2 3 by 2 matrix?
No, 3 by 3. 3 by 3 should be 3 by 3 because your voltage matrix is 3 by 3, 3 by 1 or 1 by 3, as well as your A matrix is 3 by 3. So how can it be less?
No, sir. Here it says, sir, V012 P, sir. So in this matrix, sir, it is a 3 by 2 matrix.
No, 3 by 2. It is the magnitude and it is angle.
Oh, okay. Sorry, my bad, sir. Oh, না স্যার, তাহলে আমারটা ঠিক আছে স্যার। আল্লাহ,
এটা angle.
ওকে, ঠিক আছে।
Those are the angle part. ঠিক আছে, হ্যাঁ।
Okay, sir, হ্যাঁ।
So magnitudes are earlier part, later part is the angle, phase angle. For I, it is also same. The first part is the magnitude, second part is the angle associated with that. Okay, so IABC you can also find by multiplying I012 domain information with A operator. Okay, so now what I have mentioned that it is only the individual quantity like voltage, it is single phasor quantity, current phasor, single phasor quantity, or impedance, it is single phasor quantity. But if we consider or if we think of total system or circuit, in that case, if the circuit is unbalanced, okay, that means unbalanced circuit needs to be resolved to its equivalent 3 sequence component circuit. Do I clear the matter?
So can you kindly repeat again?
That means for this case, you have unbalanced quantity like voltage, right? If you have voltage quantity, you can generate its equivalent 3 sequence component. But if it is
Yes,
in
sir.
circuit scenario, that means unbalanced, not voltage, unbalanced circuit. Okay.
Okay, sir. Yes, sir.
Unbalanced circuit you have been given, and you are asked to generate its 3 sequence balanced circuit, which is sequence component circuit. Okay. In that
Yes,
case,
sir.
what you have to do, you have to think of that you have to first generate its positive sequence component circuit, negative sequence component circuit, and zero sequence component circuit. And then you have to add those 3 circuit to get the resultant unbalanced circuit. Okay, like the individual phasor quantity. If you want to get the unbalanced phasor quantity, what you have to do? You have to make the vectorical addition, right? From those sequence component to generate its final unbalanced phasor quantity.
Yes, sir.
So if it is in terms of circuit, you have to do the same job. Now we will try to see circuit level unbalanced scenario. Okay. Sequence network generation for loaded generator. If it is the generator circuit, and if it is unbalanced, or say for example it has the 3-phase system, for the time being, initially we will consider the balance scenario, then we can consider it's one of the fault case or unbalanced scenario. So if it is the circuit, okay, 3-phase circuit now. 3-phase circuit of Y core category, or 3-phase generator circuit. We have 3 ABC phase, and there you have internal EMF EA, EB, EC for the generator, and terminal EMF is VA, VB, VC. And here you have the neutral current path. Okay, ZS is there in the series path of the generator internal EMF. So if this is the case, we can write the internal EMF voltage EABC in terms of this matrix. Now, can you say this EABC in terms of EA, is it following which sequence?
Sir, AC, sir, negative.
A position, then B position is in which location? A square position, right? And C position will be in 120. So it is the ABC sequence, okay? ABC sequence in clockwise or anti-clockwise rotation. This is A position, this is B position, this is C position. So ABC position, it is following
Clockwise, sir. Positive, sir.
Positive sequence, right? So if it is given in this way, that means it is the positive sequence component for generator internal EMF, which is E. Okay. So then if we just want to write the KVL equation for the terminal voltage of first phase VA, can we write that terminal voltage VA?
Yes, sir.
Applying the KVL concept, what will be VA? Terminal voltage VA. It is the voltage, then you have some drop from the source EA, right? EA drop, EA is the initial voltage or internal EMF. Then you have some drop, which is due to ZS series impedance as well as the neutral impedance Zn. So VA will be there, right? So if it is VA, then can we complete the other phase in using that concept of KVL around that circuit?
Yes, sir.
So we have VA, VB, VC using KVL equation circuit. Now, like last class, IN can be resolved by all the three-phase current, right? A, B, C. If we just replace that IN part, we can replace that with what will be IN? You have IB, IC as well as IA.
IA.
Right. So it should be the vectorical addition. So we can replace that IN with that information, right? So when we put that information, that part will be IA coefficient will be there as well as IB and IC, like the last class of sequence impedance. Okay. So if we just extract that sequence impedance information, it will be like this. That means all the voltage, terminal voltage, as well as internal EMF, and this is the part is due to that coefficient extraction of IA, IB, IC. Okay. So what will be the coefficient of IA for the first equation VA? It will be ZS plus Zn, right? Actually minus, because you have taken minus common. So Zs plus Zn in terms of minus from the first equation, considering coefficient extraction of IA. So that will be that part, right?
Yes, sir.
What about the other coefficient? We can also extract the coefficient of IB and IC as well, right? Which will be minus Zn for IB, Zn is a minus, and IC Zn minus. So in matrix form, we can write that equation.
স্যার এই সাবটপিকটার নাম কি স্যার? আগেরটা তো ছিল সিকোয়েন্স ইম্পিডেন্স, এবারটা কি?
Right. It is the it is actually sequence component for the circuit, three-phase circuit. Okay.
ওকে স্যার।
This title you can consider sequence network. Instead of sequence component, it is sequence network now. Like positive network, negative network, and zero sequence network. Okay, last part was only the individual component like voltage, current, phasor, or impedance, sequence impedance. Now we want to accumulate those information idea to sequence network.
ওকে স্যার।
So sequence network extraction. It is applicable now for a general scenario, but we will try to observe one faulted scenario as well. So for the time we have generated or determined VA, VB, VC in terms of its internal EMF. Now we want to check the last step or the steps, similar step like sequence impedance. In compact form, we can write like that. And this VA, VC can be replaced by 0, 1, 2 domain in terms of operator A, right? In last class, we have also seen this type of concept to get the equivalent VABC, right? So here you can have also multiplying factor of other part in terms of A. Now this part, the impedance part, it is already known to you, Z012. From here it is also generated, or you can get the idea from last class as well, the Z012 matrix. This one was the Z012 matrix, and it's mentioned in last class that this position is Z0, second position is Z1, and the last position is Z2. Okay, in the diagonal matrix of that Z matrix. And then E012, EA012. Actually, generated EMF, the generated EMF is balanced. That's the only positive sequence voltage. Okay. So in this position, what about this location? Is it positive sequence? Is it the negative sequence or zero sequence position? Regarding that,
Sir, we cannot say nothing, sir. None, sir.
এইখানে দেখো, it is the positional value. You have the positional value in this side, right? So what will be the
Yes, sir.
positional value of that?
So
The
positive
given
sequence.
positive sequence, right? It is the
Okay.
positive sequence position, right?
Okay.
Last one is E0 and second last one is negative sequence position. So it is the positive sequence location. Okay. From this sequence you can then identify the location. So if this is the case, that means EA012 is this one. We can replace that EA012 with that matrix form so that we can extract the equation, which is the
স্যার আর একটু থামে স্যার আপনাকে স্যার এটা আরেকবার একটু বলবেন পজিটিভ সিকোয়েন্সটা কিভাবে হলো
you can compare that equation with that matrix, right? This EA012. So this one is the position of E0, EA0,
yes sir yes sir.
EA1, EA2. So this position has only the value which is due to balance scenario, and only positive sequence voltage presence will be there, this position. Only EA1 will be there. EA0 is 0, EA2 is 0. Okay, this actually when you put this information in that equation, you can generate the regular
Okay, sir, বুঝতে পেরেছি
voltage
স্যার বুঝতে
equation.
পেরেছি ওকে
So voltage equation you can generate the voltage in terms of 0, 1, 2 domain and for phase A. Okay. So this is the outcome of this circuit equivalent. Now, interesting fact, this one. This one is the circuit or sequence network in terms of positive one, right? Because it is denoted all the information in that circuit, the first part of the circuit, all the voltage, internal EMF is there, and this is the terminal EMF, terminal voltage, and this one is the current due to positive impedance, right? Positive sequence impedance. So this circuit is positive sequence network now, okay, which contains positive sequence voltage, current, and impedance, all the three in a single circuit, right? So this part is the sequence impedance in terms of positive one. Second one, you can have Z2, I2, V2, VA2. So this part is the negative sequence circuit or negative sequence network. Okay, and this is zero sequence network. So here you can see only this part has the source. Negative and zero sequence does not have any source, because from this equation we can find that. First equation you will have only what? Zero in terms of drop over that Z0 impedance. So from this equation and the circuit diagram, we can conclude only for positive sequence you will have the source, but for negative and zero you don't have any source. And this is the scenario to extract the sequence network from the circuit level. Yes, if you have been given any circuit, three-phase circuit, the sequence component of that circuit will be in terms of sequence network, positive sequence network, negative sequence network, and zero sequence network. Okay. And okay. Is it clear? This part is crucial.
yes
Like phasor quantity, you will have only one quantity, but now you will address the three in a single circuit level. That means this circuit contains all the three, right? voltage is there, current is there, as well as impedance is there. That is the combined effect of that all the three phasor quantity. And you will have internal EMF only for positive part. So the three sequence impedance sequences are independent. Positive sequence network is same as the one line diagram used in the studying balanced three phase currents and voltage. Only the positive sequence network has voltage source. That's the main point of this derivation. Okay. This third one, important point. Only the positive sequence network has voltage source. Positive sequence current cause only positive sequence voltage drop. There is no voltage source in the negative or zero sequence network. You can see here, you don't have any voltage source for the negative and zero sequence network. Negative and zero sequence current cause negative and zero sequence voltage drop only. The neutral of the system is the reference for positive and negative sequence network. So grounding impedance is reflected in the zero sequence network as 3Zn. Okay, let's check one fault scenario. What are the possible fault you may have? Single line to ground fault you may have. You may have line to line fault between two lines. You can have double line to ground fault as well as three phase fault. Okay, these are the possible fault you may have in the three phase circuit. Okay, when it is three phase, one of the three phase may have short to the ground in terms of fault impedance ZF. Okay, here you have B and C phase normal. Phase A is somehow shorted to ground in terms of fault impedance ZF. Okay. So in general, or if you just want to get the idea for fault scenario like single line to ground fault, can you relate that thing to in a practical case? That means when do we have this type of fault or single line to ground type? In which scenario you may have these types of fault, or you can you give some example of that types of fault?
স্যার লাইন থেকে গ্রাউন্ডে স্যার যদি তার কেটে নিচে পড়ে যায় স্যার,
মার্কেটে পড়ে গেলে শর্ট হবে কিভাবে?
মানে গ্রাউন্ডে ওকে মানে মানে ওকে না মানে স্যার যে কোনো মেটাল কন্টাক্ট সারফেসের সাথে যদি লেগে যায় এরকম
সেটা হতে পারে, কিন্তু
পাখিটাকে
জেনারেলি বসলে গ্রাউন্ড হবে কিভাবে?
গ্রাউন্ড হলো না, হ্যাঁ
গ্রাউন্ড করতে হবে, কিভাবে গ্রাউন্ড করা যায় বলো?
আবার জোর করে কেন ফল্ট করছি স্যার?
জোর করে না, এটা পসিবল, প্র্যাকটিক্যালি তো হয়।
ওকে ওকে
মানে জোর করে বলতেছি না, মানে জোর করে এরকম ফল্ট পসিবিলিটি কখন হতে পারে এটা আমি জানতে চাচ্ছি। ফল্ট পসিবিলিটি জেনারেল, তো এটা কমন ফল্ট, জেনারেল ফল্ট। সিঙ্গেল লাইন টু গ্রাউন্ড ফল্ট খুবই কমন ফল্ট, or sometimes it is known as phase fault. তো এই ফল্টটা বেশিরভাগ ফল্টই এই ফল্টটা হয়। তো এই ফল্টটা কোন সিনারিও বা কখন হতে পারে?
বৃষ্টি পড়লে?
হ্যাঁ,
বৃষ্টি পড়লে স্যার।
বৃষ্টি পড়লে কিভাবে গ্রাউন্ড হবে?
ওই যে স্যার
বৃষ্টিটা তো আলাদা হয়ে যাবে না?
ছোট একটা হিন্ট দেন স্যার, তাহলে
হিন্টটা দিচ্ছি, কাছাকাছি গেছো কিন্তু একটুর জন্য মিস করলা। এটা হচ্ছে তোমার ঝড় বৃষ্টির সময় গাছের ডাল ভেঙে যখন পড়ে, গাছ তো পড়ে না, লাইনের উপর তো গাছ পড়ে থাকে অনেক সময়, পড়ে না ঝড় বৃষ্টির সময়? তো এটা হচ্ছে ঝড় বৃষ্টির ঠিক আছে, কিন্তু পানি না, সেটা গাছ পড়তে হবে।
গাছ পড়তে হবে, ওকে স্যার।
বুঝছো? গাছ পড়লে কি দাঁড়াবে? জেড টা হয়ে যাবে গাছের ইম্পিডেন্স।
হ্যাঁ, ওকে, ইয়েস স্যার।
তাহলে তোমার
ফল্টটাকে আমরা কি বলবো স্যার? এটাকে আমরা বলবো শর্ট সার্কিট।
হচ্ছে কি ফল্ট হলো? এটা শর্ট সার্কিট ইন টার্মস অফ সিঙ্গেল লাইন টু গ্রাউন্ড। যেমন গাছটা যদি তোমার একটা লাইনের উপর পড়ে, তাহলে হবে কি সিঙ্গেল লাইন টু গ্রাউন্ড ফল্ট। ঠিক আছে, তোমার গাছটাও থাকলো আবার ফল্টও হয়ে থাকলো। এটা তো জেনারেল নাকি? আমরা জোর করলাম? হ্যাঁ, এটা ন্যাচারালি হয় এরকম ফল্ট, কমন ফল্ট। So if we have this type of fault, in that case, what we have to do, we have to make the system sequence network. Okay. If we have this type of fault, we have to generate its sequence network, like positive sequence network, because it is now fault, and fault will have unbalanced nature, right? Initially, it might be balanced, but now it is unbalanced due to that short circuit fault in terms of single line to ground. ওকে, এই গাছ যদি আবার দুইটা লাইন নিয়ে শর্ট করে থাকে তাহলে কিন্তু আবার ডাবল লাইন টু গ্রাউন্ড ফল্ট হবে সেটা, বুঝছো? মানে
Okay,
গাছটা
yes, sir.
পড়ছে একটা তারের উপর পড়লে একরকম, দুইটা তারের উপর পড়লে একরকম, আবার তিনটা তার নিয়েও শর্ট হয়ে থাকতে পারে, পসিবিলিটি তিনটাই হতে পারে, বুঝছো? তো মানে থ্রি ফেজ ফল্টও হতে পারে, তিনটা পসিবিলিটি হতে পারে। আর আরেকটা পসিবিলিটি যেটা বলা হচ্ছে যে ডাবল লাইন ফল্ট, মানে লাইন টু লাইন ফল্ট। এই ক্ষেত্রে গাছের কন্ডিশনটা কম, সেক্ষেত্রে ইন টার্মস অফ লাইন যদি শর্ট হয় বা কোনো একটা মেটাল বডির কারণে দুটা লাইনের ভেতরে ইন্টারনাল শর্ট সার্কিট হয়, সেক্ষেত্রে সেটার পসিবিলিটি হতে পারে
Okay, sir. Okay.
ডাবল লাইন ফল্ট, এটা নট গ্রাউন্ড বাট ইন টার্মস অফ লাইন টু লাইন ফল্ট। So we may have three types or four types of four categories of fault: single line to ground, double line to ground, line to line, three line to ground. Only the three line to ground fault is balanced fault. Okay. এখন আবার বলবা যে ফল্ট হইছে আবার ব্যালেন্সড হলো কিভাবে?
Yes, sir.
কারণ তিনটা ফেজেই একই শর্ট সার্কিট বা ওভার কারেন্ট পাবে।
Okay, sir.
ফল্টের কারণটা হচ্ছে যে তোমার ইম্পিডেন্স, ইউর ইম্পিডেন্স ফর ইম্পিডেন্স উইল রিডিউস। কেন রিডিউস হয় ফল্ট হলে?
স্যার ওই যে শর্টেড হয়ে গেল তো স্যার, শর্ট সার্কিট
শর্ট
মানে
হয়ে
তো
গেলে
স্যার
ইম্পিডেন্স কমে কেন?
হাই
কারেন্ট বেড়ে
কারেন্ট
যায়।
কারেন্ট বেড়ে
কারেন্ট তো
যায়।
বাড়ে, কিন্তু সেটা বাড়ে হচ্ছে ওই ইম্পিডেন্স কমার ইফেক্ট হিসেবে। কারণটা হচ্ছে ইম্পিডেন্স কমে যায়। ইম্পিডেন্স কেন কমে? ইন টার্মস অফ
because, sir,
সার্কিট আইডিয়া,
হ্যাঁ, sir.
যখন তোমার সার্কিটটা শর্ট হয় তখন প্যারালাল সার্কিট ফর্ম করে না? আর প্যারালাল
হ্যাঁ।
সার্কিটের ইম্পিডেন্সটা কি দাঁড়ায়? জেনারেল
কমে
নেচার
যায়
থেকে
ইনিশিয়াল
কমে যায় না?
থেকে। Yes, sir.
তার মানে তোমার when you have fault, your parallel circuit will reduce the impedance effect that will actually cause over current or short circuit current in terms of fault. Okay.
Yes, sir.
তো যেটা হচ্ছে তোমার এখন কারেন্ট বেড়ে গেছে, কিন্তু এটা ফল্ট হিসেবে বাড়ছে। সেজন্য বললাম ব্যালেন্স ফল্ট আর রেগুলার সিনারিওর ভিতরে ডিফারেন্স হচ্ছে যে রেগুলার টাইমের কারেন্ট রেটিং কম থাকবে, ঠিক আছে? আর ব্যালেন্সড ফল্ট হলে কারেন্ট রেটিংটা বেশি থাকবে, কিন্তু তিনটা ফেজেই থাকবে সেম কারেন্ট। ডিফারেন্সটা মানে তোমাকে আইডেন্টিফাই করতে হবে whether it is regular scenario or it is the balanced fault. ব্যালেন্সড ফল্ট কিন্তু ফল্ট থাকবে, কিন্তু তিনটা ফেজেই একই ফল্ট থাকবে।
বুঝতে পেরেছি স্যার।
এটা হচ্ছে তোমাকে আইডেন্টিফাই বা ডিস্টিংগুইশ করে নিতে হবে এই সিনারিওটা আসলে কোন জায়গায় গেল। এখন হচ্ছে if we can concentrate on single line to ground, single line to ground, it is in that diagram only phase A has that fault, right? From single line to ground. So phase B or phase C, it doesn't have any fault. So if we just want to write the terminal voltage in terms of phase A, which is ZF IA, ZF is the fault impedance. Or regarding fault impedance, don't confuse with say fault impedance with the neutral impedance. Okay. Now you have ZS series impedance, ZN neutral impedance, and ZF fault impedance. So ZN has three possibility, right? Which I have mentioned earlier in this class.
Yes, sir.
Solid ground, resistive ground, reactive ground. For ZF, you have two possibility, bolted fault and normal fault. That means bolted fault will have ZF as 0. Okay. So if you have bolted fault case or scenario, in that case, you will not have any ZF value. It will be mentioned only bolted fault. In that case, you have to put ZF as 0. Beside that, ZF will have some value. Okay. So now as this circuit is balanced or not. If it has fault scenario like single
No,
line
sir.
to
Then it
ground,
is unbalanced.
unbalanced, and if it is unbalanced, you know, unbalanced circuit has component, right, or network. In terms of phasor quantity, it is sequence component. In terms of circuit, it is sequence network. Okay, both are same. So sequence network is there. So sequence network. So what we have to extract? We have to generate it is equivalent sequence network from the derivation. Okay. And in this type of derivation, you have to know the process or step. Don't memorize that. Only the outcome or result you have to use. But how it is achieved, you have to know the step. Yeah. So VA will be ZF IA. This is the drop over that terminal voltage, and we know already we don't have any phase or short circuit in that two phase. So you have only zero current because we don't have a path to complete the current flow to the ground. So IB and IC 0. Actually, single line to ground may be on second phase also. That means IB can be there. Okay. In that case, you have to write the equation accordingly. Have you got my point? For this case, fault is in phase A. That's why the
Yes, sir.
equation is written like this. It might be on second phase as well. That means this IA and IC in that case will be 0, and your VB will be ZF IB. Okay, you have to write the equation on the situation. So substituting IB IC. Okay, we know the sequence component matrix in terms of 0 and ABC, right? How 0 and ABC are interrelated? 0, 1, 2 domain and ABC domain are interrelated in terms of A or A inverse.
Sir, আরেকবার একটু বলুন স্যার, ABC
ABC and 0, 1, 2. If we want to relate those two, that means you have I0 ABC, sorry, I0, 1, 2 equals I.
Sir, A into ABC, A into ABC.
A into
মানে
ABC or A inverse.
A inverse into ABC, my bad.
A inverse into ABC will give you 0, 1, 2, right?
Yes.
So this is the form. This is IABC, and this is A inverse, and this is 0, 1, 2. Okay. But here you can see B and C is 0 because of single line to ground fault. Based on fault nature, you have to put that 0. Okay. Which phase it is fault? It is only phase A fault. So phase A will have some current, but other phase will not have current because they are not having any fault or something like that. Okay. So if it is phase B, you have to write IB and IA would be 0. You have to write the equation properly. So above equation, okay. When we make the normal multiplication of that matrix, what will be the value of IA0 from this matrix? What will be IA0?
Sir, IA0 will be IA,
IA.
1/3 IA, 1/3
1/3
IA.
IA, right? This is IA0 equals 1/3 IA. You can check IA1 as well. What is the value of IA1?
IA1 0, তারপর একটা না ভুল বলছি।
IA1
1/3
এটা
IA।
Why IA1 will also be 1/3 IA, right?
সবগুলোই
Likewise,
1/3 IA।
সবগুলো 1/3 IA, right? This is actually written here. IA0 is 1/3 IA, IA1 is 1/3 IA, IA2 is as well 1/3 IA. Okay. So and we also know voltage case symmetrical component VA is actually the starting point where we have started the journey. That if you have unbalanced phasor quantity, because VA is the unbalanced, because we have single line to ground fault. That's why we have to generate its component, symmetrical component. VA0, VA1, and VA2. Okay. Up to now, it's okay. We have
Yes.
not derived the total derivation yet for up to this step. Now we want to see what is going on after that. Now we know VA0, VA1, VA2. Those information from the earlier derivation, like the derivation of internal EMF in terms of what we can say, terminal voltage, last derivation. What we have generated, VA0. Let's go there. VA0. Yeah, VA0, right? VA0 is this equation. That's last derivation. Okay, VA1 and VA2. This was derived in last option. So when we take common of those information, what will generate? Or if we just add these three, what will happen? EA minus all the impedance and IA0 or IA1 or IA2, right? If we add all the
Yes,
three,
sir.
what will be there? This part, and the remaining will be in minus sign, the impedance.
Yes, sir. একটা matrix হবে স্যার এখানে, হ্যাঁ।
ম্যাট্রিক্স হবে, তার আগে হচ্ছে ওটাকে কমন করলে এটা আসছে। এই যে এটা হচ্ছে, দেখো ভিএটা ইএ ওগুলা সবগুলো অ্যাড করছি, এই যে তিনটে অ্যাড করছি ওই ভ্যালুগুলো। If we put all this VA0, VA1, VA2 in this equation, in terms of that EA will be there and the remaining part will be other side, and in terms of IA0. And we know Z0, this is sequence impedance in terms of what? VA, this is the zero sequence impedance ZS, Zn, considering only the self and neutral impedance. We have not considered the mutual coupling effect here. So VA will be, this VA is already there, the earlier stage, that means here, VA. Okay, VA is the drop due to fault impedance, IAZF. Okay, VA is there. So IA, we know IA is 3 IA naught, right? Here you can see IA is equals to 3 IA naught. If we just give that direction, so VA will be ZF 3 IA naught, right? So in left side it is VA, so we have put 3 IA naught ZF, and in right side the remaining part. And as we know, Z0 information in terms of ZS plus CZN, and it is actually from sequence impedance derivation in terms of Z0 sequence. When we take this part, that means IA0, what will be there? If after some simplification we can get, right, common, taking common of IA0, all this ZF will be in their direction, or you can take all that in other side over this impedance Z1, Z2, Z0, and this 3 ZF is also there, right? So this is the actually IA0, and IA0 is not our target. Our target is IA. This is the fault current. So IA is 3 IA naught, and IA value, if we just put that, we can generate that. Now, if we have the equation, can we draw its circuit level sequence network? We have zero sequence impedance. We will use negative, positive, as well as source, and this is the neutral fault impedance. So that will be the diagram for that single line to ground fault based on that equation. Okay, this is the positive sequence network, negative sequence network and zero sequence network, and how they are related or interconnected in terms of IA naught. Okay, IA naught, and this is the, you have some, this is ZF, that means this, when you add all the three impedance, you will get the total current, which is fault current due to this sequence impedance, sequence network. As I have already mentioned, the solid ground issue, Zn is 0. For voltage fault, ZF is 0. Okay, so can you generate this sequence network from the fault equation, this fault equation? It might be different for different fault scenario. Okay, for the time being, we have discussed the single line to ground scenario. We have other fault issue also. When we cover all the fault, you will get the difference between different sequence network for the fault. Okay, so for the time being, we have discussed only single line to ground fault. Okay.
স্যার আমরা আজকে এখানে থেমে যাই স্যার, আজান দিয়ে দিয়েছি স্যার।
আচ্ছা ঠিক আছে,
এখন স্যার মনোযোগ নেই আর স্যার আমার অত স্যার।
we will okay, this is the topic only we have covered single line to ground fault. From next class we will discuss the other fault so that you can make correlation between them. Okay,
স্যার আপনি স্যার একটা কুইক রিক্যাপ দিয়ে দেন স্যার, এটা একটু ক্লাসে স্যার নেক্সট দিন আমরা শুরু করব, যেটা একটা রিক্যাপ দিয়ে আমরা নতুনটা পড়ে ফেললে বেস্ট হবে।
হ্যাঁ, এটা মাথায় রাখবা যে আমরা সিঙ্গেল লাইন টু গ্রাউন্ড ফল্ট we have started. Okay, so that you can compare the other fault with that.
Yes sir, yes sir.
Okay, remember that circuit also, that circuit is there which are interconnected based on this equation. Okay, thank you all. Thank you all. Who is taking the recording, please stop. Yes.